Hi class, so I had a request to make a video for calculating standard deviation, and I'm going to go through each of the steps. This is from the variability lecture, but on the slide I have 5 scores, and then I have the equation for sample standard deviation. So in order to calculate, so let me go through the equation first. So this S stands for standard deviation. Within the, so we have to, at the end we have the square root, but within the square root, we have x minus x bar, and then we add up all the squares of x minus x bar all over the sample size minus 1. So we have to calculate first x bar, which is the mean for the average. So I have my numbers here. So the mean will be, you add up all the numbers and you divide it by the total number of numbers that are in the data set. So it'll be 10. So I get a mean of 6. Hopefully that's correct. And then I already pre-wrote x minus x bar here. So I'm going to calculate all the x minus x bars. So what this will be is, an x is the data point, okay? So I'm going to do 1 minus 6, then 9 minus 6, 5 minus 6, 8 minus 6, and 7 minus 6, okay? So 1 minus 6 is negative 5. This is 3 minus 1. In order to calculate the next part, because I want to add up all the squared deviations, these are square deviations now. So I'm going to add this, so I'm going to calculate the square of this. Right, so I already calculated this part. So I just need to square this. So 5 times 5, so essentially this is negative 5 times negative 5, and that equals 25. Then 3 times 3 is 9. Negative 1 times negative 1. Negative 2 times negative 2 is 4. And 1 times 1 is 1. Okay? So then, because we have this part of the equation, we just need to add all these up. So it'll be 25 plus 9 plus 1. So all of these square deviations, I get 40. So that's the top part of the equation now. So we have to do the square root of 40 over n minus 1. So there are 5, right, samples in my data set. So it'll be 5 minus 1. So this will be the square root of 10, which is 3.16. So that's what I get for the standard deviation for the sample.